Hello everyone, this is Mugilan from K.S.Rangasamy College of Technology. So in this video we are discuss about image compression, particularly Huffman and run length coding for compressing image. So first of all we will discuss about the introduction to data compression. So why this data compression is necessary and what is meant by data compression, how the data is compressed and the possible manner. What do you mean by lossy and lossless compression? So static, adaptive and hybrid compression. So the compression utilities and the different compression formats, so run length coding and Huffman coding, the prefix property. So these concepts we'll discuss one by one. So what is data compression? So the compression is the representation of an information source, that is data file, either it is a speech signal or image signal or a video signal accurately. This is a possible way of using the fewest number of bits. So the compressed data can be used only to understand if the decoding method is known by the receiver. So the both encoding and decoding must be perfect for a perfect compression of data, either it may be image, video or signal. So why we need data compression? So for data storage and transmission, and this can be reduced by processing the data, and the disadvantages may be as the extra processing is required for compressing and decompression. So the design of the data compression scheme may be having the trade-offs between various factors, including the degree of compression, the amount of distortion, and the computational resources required to compress the and uncompress the data. So mainly this data compression is used to reduce the storage area and the transmission and reception power, reduce the transmission reception power. So how the data compression is possible means, so the information usually contains redundancies or the information that is often repeated. So example, in reoccurring letters, a number of similar pixels or same intensity level of pixels. So the file compression program remove this redundancy. So reducing the by means of reducing the redundancy, this data compression is possible. And different types of compression techniques are lossy and lossless compression. So this lossless compression, to exact reconstruction is possible in the lossless technique, and it exploit the redundancy in data and apply to general data. The examples for lossless compressions are run length of MON and LZW codings. So in the lossy compression, you will lose certain amount of information, that is permanently eliminating certain redundant informations. So they exploit the redundancy and human perception, and it can be applied for audio, image and the video formats. So the example for lossy compression are JPEG and MPEG types of compression techniques. So the lossy techniques usually achieve higher compression rates than the lossless ones, and it is more accurate. So the classification of lossless compression, that is Huffman coding, LSW, or some of lossless compression, and the algorithm with the hybrid can also be using for completely static or completely dynamic. The different formats and utilities for compression techniques, for example, spin zip, pk zip, compress, zip. These are some of formats for using compressed folders. So general compression folders .zip.gz. So for image compressions, we can have a JPEG 2000, BMP, GIF file, PCX, PNG, TGA, TIFF, WMP. These are some of image compression formats. So audio compression, generally known as MPEG, real audio, AFF, wave, and like that. Then common video are the both sound and image compression formats. So DivX formats, MPEG formats, so Windows Media video for Windows, AVI format, that is FLV format, another one, Flash video. These are some of the compression formats we are using for folder compression, image compression, video compression, and all. So the run length coding, um, the following string is given, that is BBB, BHHDD, XXXX, KKK, WWZ, ZZZ. So you can represent the repeated alphabets in numbers, that is 4B, 2H, 2D, 4X, 4K, and 2W, 4Z. You can represent by means of alphabets in number is known as the run length encoding. So once transmitting by means of this run length encoding, we can decode in the receiver side by extracting the informations. So this is the basic concept of run length coding. So Huffman coding, in Huffman coding assigns variable length codes by means of symbols based on their frequencies occurrences in the image. So the low frequency is encoded using many bits, and high frequency symbols encoded using fewer bits. So this is the main concept, that lower frequency using many bits, higher frequency are encoded using fewer bits. The message can be transmitted, is first analyzed and find relative frequencies, and then the coding process generate binary tree, the Huffman code tree with branches labeled with zeros and ones. The Huffman tree is generated and can be compressed information to enable receiver decode the message. So static Huffman coding algorithm. So this algorithm, um, find the frequency of each character, the distinct character, create one side binary tree and insert the one binary tree in priority manner, and repeat the same thing. So for example, the static code, the character A, E, I, N, O, S, T is given, and the frequency is 4, 5, 6, 5, 1, 3, 4, 5, 1, 8, 2, 2, 5, 3. So the build upon tree and find the code word for each character, and the data consists of these characters, which is total number of bits to be transmitted. Verify the computed Huffman code, satisfy the prefix property. So the static coding example is given here, and the 31 is represented 13 plus 8, that is IGO, and the 45A, 45N. The tree based one is converting. So 53T, 53. So 53 is represented 22S, 31, and the 31 is represented 13 and 18. And this 106 is represented 53, 53, and 23, 31, and 13, 18. So the coding example, how to encode by using the Huffman coding is given in this example. The Huffman code word is created for A is 110, E is 10, so it's 0110, N is 111, and 0 is 0111, and S is 010, and T is 00. So the final code bit and frequency is given here. That is, sum of the code words is 696. So this is the final outcome of this static Huffman coding. That is in binary significant bits, and the characters are in 8-bit ASCII codes. So the prefix property is data encoded using Huffman coding, unique decodable. This is because of Huffman codes satisfy an important property called prefix property. Huffman code word is prefix of another Huffman code word. For example, these code words 10 and 101 cannot simultaneously be valid. Huffman code words because of the first is the prefix of the second. Uh, so that's all about the concepts related to compression techniques, and particularly for run length coding and Huffman coding. Thank you. Thank you everyone.